Okay. All right. Welcome to Stats 243. I'm so excited to get started. Uh, you'll notice, hopefully, you notice that I really, really love what I do. You should see me twice in the Zoom meeting. One of them, I have another computer over here. So if you see me peeking over there, I have another computer that I have the chat up. So if you send me a message through chat, I will look over there and I'll be able to answer it. I will read the question or paraphrase the question so that those who are being recorded, watching the recording can see what it is, and then I'll answer it. Feel free to ask each other questions. I won't read those out loud. If you ask each other questions in there, that's fine. I've even had an occasional class clown decide to post strange stuff in there. I don't care. You do whatever you want with it. I will peek over as long as it's appropriate. I will peek over there and things that pertain to me in this class, I will read them and I will answer the questions. If you have a question otherwise, just unmute and ask it because I have a really hard time seeing like hands raised and things like that. So since I have my screen shared, I can't always see that. My other computer is being wonky. Anyway, so, um, just feel free to unmute and ask the question. I am not going to require you to have your screen on. You don't have if you want to. I love being able to see faces and I love being able to see like body language so I can see if somebody looks really confused or if maybe they're still writing the notes or whatever. I love being able to see those things. But you don't have to. If you are not comfortable with it or you want to keep your camera off, or maybe you have a cat that's being a nuisance and you decide you don't want the world to see your adorable cat, feel free to just to go off the screen. It doesn't matter to me. I like to see you, but I don't have to see you. I'm not going to be upset by that. I had something else that was important. Um, Oh, I highly recommend printing off the PowerPoints before the class. RCC you can print for free. So I would recommend printing. Okay. RCC you can print for free and you can print two slides to a page and then print front and back and it takes a lot less paper and you can use RCC's paper. That way you're not using your own. And then you can take your notes directly on the PowerPoints that I teach from. Hold on a second here. So you can take your notes directly on the PowerPoints that I teach from, and then you can use those notes on your test. So it is super helpful to be able to uh, write directly on the PowerPoints. So today's PowerPoint is mostly vocabulary. So it's not a huge deal if you haven't printed this one out, but maybe before Thursday's class, if you want to print that one out. So some of them are going to be kind of long, and I apologize for that, but it is what it is. Print those PowerPoints, use that. You don't have to, obviously, but it's a lot of people have used that as a tool and have loved it. When I think of it, I will tell you things like, hey, this is something I am going to use it's going to be on the test. This is something super important. Put a star here. Or I might say, hey, you might want to tab this page. You're going to go back to it over and over again. Or I'll tell you, this is something I have to teach you, but I'm not going to test you on it. I will try to do that whenever possible. So I'm not in this for surprises. I'm not trying to trick anybody. I'm not the kind of person that's like saying, "Oh, surprise. This page 83 in the book is covered in 8 questions on the test, but I didn't even tell you to read it." I'm not that person. We've all had those professors or instructors, haven't we, where they've been like, "Oh yeah, lecture in class. Oh, by the way, the test doesn't cover the lecture in class. It only covers what was in the book." So I don't want to trick you. I want you to really learn. So now that I've said all that, chapter one, we're going to cover chapter one today. It is all the vocabulary. It is kind of boring, and I apologize for that. But learning stats and probability, it is a kind of a new language. And so in order to learn a new language, you need to learn new vocabulary. So I'm going to teach you that vocabulary in chapter one. We're going to go through all of that stuff, all the boring stuff. And then we're going to just dip our toe into chapter 2 in section 2.1. After the chapter 1, you will have enough knowledge to do the chapter 1 homework, which is for your which is for your attendance. That needs to be done by Thursday at midnight so that I can mark you here. Because that's the only way that I'm going to mark attendance is by looking at did you complete that first assignment? We are required to have you complete an assignment. And Marissa, you have a dog on your lap? I want to see this dog. Oh, what a cutie pie. Okay, sorry. See, I get distracted. It's so cute. Okay, see, those of you that are just listening to the recording, you are missing out on this cute dog. Okay, I told you I get distracted. All right, let's go. Let's just jump right into it. Okay, let's start simple. Let's start with what are statistics? What is statistics? It is a science. So many of you who have taken science classes, so I know I have a lot of people going into the medical field, so I know you've taken some science. Statistics is a science. It uses the scientific method, but it is a science of data. It is for collecting, organizing, summarizing, analyzing. We will put it into graphs. Oh, put it into graphs, we put it into tables, we draw conclusions, and we hypothesize. All of that stuff happens within the under the umbrella of statistics. It is a science. We also can draw conclusions and we will have a measure of confidence with the conclusions. Now, this stuff happens a long time from now, like chapter 9, but that's kind of what we do as statistics. The information that we're gathering is called data or data. I don't know which one is correct. I think they're both correct. I use them both sometimes in the same sentence. So that information is data. Now, one thing I hate about data is that data is plural. Data are plural. The word data is a plural word and I don't like it. Most of the time, I will just use it as singular, though it's wrong. But I am okay being wrong in this case. So data are plural. It just is what it is. So the data that we have is the information that we use to draw conclusions. It could be numerical, like height or weight or number of cats in your household. I only have one. Or it can be something non-numerical, like gender or handedness, like right or left-handed, or color of hair, color of M&Ms in a bag, things like that. But it describes a characteristic of an individual. So we are going to use data to offset anecdotal claims. We're going to use it to prove a point. I love using it to prove a point. I will give you some examples of where I've used it in real life to prove a point as we go through. And it's fun because people look at you like, oh, maybe I'm not telling the truth. You just proved mathematically that I could not possibly be telling the truth. It's fun. Okay, we're also going to kind of look at when data is being misused and when it's misleading. So that's what we're doing here. And I'm going to move on. All right. So important vocabulary. You will be asked in your homework about population, sample, and an individual. So the population is your entire group. Now, I'm not going to ask you in your test for population, sample, and individual. Oh, wait, I am. There's one question on your test I just remembered. Sorry. Population is the entire group being studied. So if I was trying to figure out a study of RCC college students and is there a correlation between how much time they study and the grade they received, my population is all of RCC students. Now, I'm probably not going to talk to all of them, but that's my population. I'm trying to make a decision or decide based on, sorry, we're trying to like draw conclusions and apply it to the entire RCC population. So then next is a sample. So the sample is a subset of the population. So a sample would be if I selected 50 RCC students. So if I took a sample of 50 students, those 50 students are my sample. I'm going to use the information that I garnered from those 50 students to apply it to the entire population. So next is the individual. So one RCC student is an individual. And so the one individual, so we have like one RCC student, that is the individual. So when we take, sorry, I just got distracted. I don't even know what distracted me, but I just got distracted. So the one RCC student is an individual. So it's one person out of the whole RCC. So it's just kind of subset and then a subset of that and then one of those. Individual doesn't have to be a person. An individual is could be like one individual M&M, or it could be one individual cat or one individual piece of clothing or whatever. So it doesn't have to be a person. That's what I was going to say before I distracted myself. All right. Okay. So if was an in-person class, I would as everybody walked in on the first day, I would give everybody a post-it note so that we can do something anonymous. Everybody would have a post-it note, and then I would have you write down your answer to this question. You're walking down the street, you notice that a person walking in front of you drops $100. Nobody notices the $100 except you. You could keep that $100 and nobody would know that you kept it, or you can return the money to the owner. And if you were in an in-person class, you would answer one way or the other. You would write on there keep or return, and then you would give me the post-it notes. I can tell you I have never had a class that 100% of the people returned the money. I don't think I've ever had more than two or three say they'd keep it, but I've never had 100% of the people said they'd return the money. So we're going to just decide. I think I have 60 students in this class, not in person right now here, but in the Blackboard class. So I'm just going to use 60 as a reference. So let's say that 57 out of 60, 57 out of 60 returned the money. So I'm going to do the math right here on my little calculator. 57 out of 60, that's 95%. So in this case, in this imaginary class, 95% will return the money to the owner. So if our class is a sample of all of the RCC students, so if I was going to apply this to all of the RCC students, this would be a sample. So we have a sample of size 60. So if we are talking about a sample, we refer to it as a statistic. So sample is a numerical summary, or statistic is a numerical summary of a sample. So we have a different word for population, and we'll get to that in a couple minutes. So now descriptive statistics. Descriptive statistics describes the data through summaries, tables, or graphs. So I'm still not making any inferences, but if I put it in a table or I give a summary or I put it in a graph, something like that, that would be descriptive statistics. I am not going to ask you to tell me the difference between statistics and descriptive statistics. I'm not even going to ask you, hey, is this descriptive statistics? I'm not going to ask you that. This is just some vocabulary. So I had some results. I didn't draw any conclusions, so I'm just describing what I saw. All right, let's move on. So once again, 57 out of 60. So I have 95% of my class would return the money. So now if I took this result and I extended it to the entire population of RCC, to all students, I'm making an inference. I'm inferring something from my data. So I am saying that I think, let's say between 92% and 98% of all students would return the money. So we're going to get into this in chapter 9 about how I calculate that 3% difference, the 3% below and 3% above. But because I have a sample, I can't say exactly, precisely 95% of all RCC students would return the money. Because it is a sample, then it could vary from that a little bit. So I do 92% to 98%. It gives me this nice interval that probably that's the amount of RCC students that would return the money. We're going to get into the math behind it later. This is just kind of the overview of what we're going to be doing here. Any questions so far? Are we doing good? All right, make sure you stop me. Sometimes I get excited. I love what I do. So sometimes I get excited, start moving too fast. So you stop me if I start doing that. All right. Suppose that out of all of the RCC students, 84.9% of them have a job. This is called a parameter. Because it describes a population, it is a parameter. So now if I took 250 students and I found out what percent of those 250 had a job, and it's 86.4, this is a statistic because it is based on a sample. So these are the two things you're going to need right here. Your homework and quiz one will ask you whether things are a statistic or a parameter. So your homework and the quiz one are going to ask you that. So in inferential statistics, and what we're doing in this class, we're going to take the statistics that we calculate to estimate the parameter. We're going to take our sample and use it to estimate a population. So that's what we're doing here. But these two things right here. So when you're taking your test or you're doing your homework, it is not always going to have the word sample in it. But it'll talk about like, out of the 250 students taking math at RCC, or I don't know, it will bring it down to a lower number. It will somehow like reference a sample. So it might not say the word sample, but it might say something like we selected 50 students from RCC and found that 84% of them had a job. That's a sample. But if I say out of this whole class, out of all of the students in this class, 95% would return the money. I'm implying that this class is my population. So it's not always super, super clear. Just try to pay attention if they're implying that there is a sample. So there should be some sort of an implication there. Any questions on this? We doing okay so far? Make anybody fall asleep yet? Okay. I'm sure the cat will knock something down loudly and wake you up here pretty soon. She does stuff like that. She's being kind of wild over here. All right. I am not going to ask you to give me the process of statistics. I'm not going to ask you to recount this to me, but I want you to kind of have an idea of what that process is. So, the first thing we do, and this is similar to the scientific method. There's a lot of similarities here. Um, once we add more vocabulary later on, there's a way we can make this sound even more like the scientific method. But first thing we want to know is what is our research objective? What question am I trying to answer? What question am I trying to answer, and what is the population that I'm studying? So that's what we need to figure out first. Before we collect any data, before we do anything, we need to figure out who are we studying and what do we want to know. After that, then you collect your data. Now, generally, we cannot poll an entire population. Usually we can't. So we need to look at a sample. Now, it's very important that when you collect your sample, you do it well, that you do it correctly, because your entire study can be debunked if you don't collect your data correctly. Random samples are the best. So a simple random sample. So if you're studying the all of the RCC students, let's say that you can get if you're studying all RCC students, you probably are going to have some sort of access to their data. A maximum how many people that yes, so we have a 5% rule. This is really interesting. Okay. So there is no minimum on how many people you can sample. So the question in the comment says, is there a maximum to how many people can be part of a sample before it's considered something else? And is there a minimum to how many people are needed for it to be considered a sample? Okay, so I'm going to get the maximum first. When we are sampling, we need to make sure that there is independence. I'm going to get into this much deeper as we get further into the course. In order for our sample to be independent, the sample size needs to be less than 5% of the population. So if we're taking a sample, it's going to be less than 5% of the population. So a minimum. Now, With a minimum, it's tough because there's technically no minimum. But if I took a sample size of 3, it's probably not going to be a very good sample. And so remember when back here I did this between 92 and 98. So if my sample size is smaller, this range would have to be greater. So if I had a sample size of like only like, let's say 5 students out of the entire RCC, this might change it to something like between 80 and, I don't know what, say 85 and 100% instead. It's going to change it to something so that it's almost useless. But we have some calculations later on that help us to determine what are good sample sizes. So I'm not going to get into that right now, but these are the right questions. You're definitely asking the right questions. So I love that. Good job. And I know I didn't fully answer your question, but those are the right ones. We will get to those answers. Okay. So there are a lot of studies that you see, a lot of the polling that you see online is called a convenience sample. So let's take a very controversial topic right now. Let's say that we're asking the question whether you approve of the way Donald Trump is handling the economy. I don't want your answers. You're not going to get my answers. But let's say that I posted that poll on the Fox News website. I am going to get very, very different results posting it on the Fox News website than I'm going to get if I put it on the MSNBC website. I'm going to get very different results. So one of them is considered more conservative and the other one's considered more liberal. So you're going to get very different results. Those would be convenience samples. The other issue is when you do phone-in polls. Like y'all remember like the days of calling in on American Idol. I know some of you are really young, so you probably don't remember that. But you used to make phone calls to call into American Idol and you would vote. Okay. So you're only going to vote if you feel really strongly about somebody. And then you're going to vote 20 times or however many times they allow you to vote. So that would not be a very good sample because you're only going to vote if you really care about something. Or how about have you ever got those like you get surveys in the email? So even like course evaluations a lot of times could even be the same thing. You know, a lot of people only do their course evaluations if they feel really strongly, if they really love their instructor or they're really mad at their instructor. You hardly ever get middle of the road evaluations. You get one extreme or the other. And they're not very reliable. So you have to be really careful with your sampling method. If you're going to do a sample now, I understand that most of you probably have jobs outside of the school. Otherwise, you probably wouldn't be taking an evening Zoom class. A lot of you have those kind of jobs. So you're not going to have a whole lot of time or patience or anything to do this nice random sample. I'm not going to expect that of you in this class. There is going to be some data that you're going to collect, but I'm not expecting you to have random samples. If you are out in the world and doing your own research, do your random samples. All right. Next, so we've collected our data, we've collected it correctly, we did all the right things. Now you're going to describe your data. So this is where we do the thing like saying like 95% of our students would return the money. This is your descriptive statistics. This is where you're just describing what happens. This is going to help you to figure out what statistical methods am I going to use to answer my research question. So number 3 is you compiling all your data. You're going to organize it into some nice pretty graphs or tables or whatever, and you're going to determine, now what do I do? What kind of math am I going to use to identify my research objective? All right, next. Now you're going to math it up. You're going to throw all of the math at it, and you're going to perform your inference. You're going to do all the math that you need to do, and you're going to report your level of reliability. Sometimes it's hard to speak. Words are hard. So you're going to say, I have my sample here. This is the sample size, going to do all this math. And then magically, you're going to have all these beautiful results that you can apply to your original question. I think next we just, oh, finally, you're going to write your conclusion and all of that. That would be number 5. It's not on here, but you need to write a conclusion of some sort and say, here's what I did. Here's my results. This is whatever that whatever my results are, here it is. 93 to 97% of all students would return the money. Ta-da! All right. Any other questions here before we look at an example? Okay. So I keep saying I'm going to change this particular example, but then after I'm a couple weeks away from it, I forget that it exists and then I don't change it. Then I'm preparing for this class and I'm like, oh, I don't have time to change it. So this one lives here and it probably will live here next term. So there's some studies out there about batterer treatment programs. But there were not very many experiments that designed to determine whether there are some treatment programs and whether or not they're better or worse, whether they're better than non-therapeutic treatments like community service. So some researchers designed an experiment. They took 376 male criminal court defendants that were accused of assaulting their intimate female partners. They were randomly assigned either into a treatment group or a control group. The treatment group entered a 40-hour batterer treatment program. The treatment group, or sorry, so the treatment group went into a 40-hour batterer treatment program. The control group got 40 hours of community service. So those are my two groups. After 6 months, 21% of the males in the control group had further battering incidents, and 10% of the males in the treatment group had further battering incidents. So the researchers concluded that the treatment was effective in reducing repeat battering offenses. So this is our scenario, this is our study, and we're going to break it into pieces. So our research objective is we wanted to figure out whether males accused of battering their intimate female partners, whether the battering treatment program was less likely to have them batter again compared to the community service. They're trying to figure out, does the batterer treatment program work? Notice it's very specific. It was males accused of battering their intimate female partners. It does not talk about male on male violence, female on female violence. It does not talk about any of that. It is very specific. Then you collect the information. So they put them into two groups. One was in a batterer treatment program. The other group was in community service. Then after 6 months, they revisited it to determine whether they battered again. That's just the information. So we didn't do anything with it yet. That's just my information. It's my data. So after 6 months, 21% of the males in the control group had further battering incidents. 10% in the treatment group had further battering incidents. I have not inferred anything. I have not drawn any conclusions. This is just my descriptive statistics. This is just the summary. The next step is where I apply it to the population. So 376, we have the 376 males that battered their intimate female partners. So what they're saying is all males who batter their female partners who participate in a batterer treatment program are less likely to batter again. So they applied that to the entire population. So my population here is males who batter their intimate female partners, not just all males. That's my population is males who batter their intimate female partners. That's it. That was my conclusion. That was it. Any questions on that, on the breaking that down? All right. Okay, we're going to jump to some more vocabulary. I told you there's so much vocabulary. Next classes after this are much more exciting, have less vocabulary and a lot more hands-on. Let's do some math stuff. Okay. Even though some of you are like, yes, no math today. I know how it is. I know. Okay. So what is a variable? A variable is a characteristic of an individual. So generally, in your algebra classes, a variable was like the letter X that stood for a number. In this case, the variable can stand for just about anything. But it's anything that varies because variables vary. If everybody had the same height, or all plants grew the same, or everybody had the same number of pets, or all houses were painted the same color, if everything was the same, we wouldn't need variables. We wouldn't need statistics. So we use variables in order to study the population. All right. Qualitative or categorical variables. I use these interchangeably. Our textbook just used qualitative, but I've heard categorical used more frequently than qualitative. So I use both interchangeably. I like the word categorical because categorical, I think categories, where qualitative, it doesn't, there's no mnemonic device for me. So categorical variables are based on some attribute or characteristic. They're usually words, but if they're numbers that you don't do math with. So it would be something like gender, like male, female. Zip code are numbers, but we don't do math with zip code. Hair color. Now, I hate that birth date is here because birth date is great if you're just saying, hey, when were you born? Then it's categorical. But if I'm starting to say, hey, my birthday's 3 days before yours, then you're doing math with it, and that takes it out of the categorical. So if it's a number, it needs to be a number you don't do math with, like a phone number. We don't do math with phone numbers. That would be categorical. But anything that is either a word or numbers that we don't do math with. Then you have quantitative. I like the word quantitative because it makes me think quantity. Quantitative variables are variables that are numerical that you do math with. So numerical measures of individuals, you can add them or subtract them and it becomes meaningful, like temperature. It was 5 degrees hotter than it was yesterday. Number of days somebody has studied. I studied 2 days more than I studied before. A height or weight. You know, my grandson is 3 inches taller than he was 6 months ago. He probably not, but just making stuff up. So it's numbers that you would do math with. Those would be your quantitative data. Any question on qualitative or quantitative? All right. Anyone, also, if I flip away from a screen and you want me to go back to it, holler at me. I will go back and I will wait. We're not in a big hurry. Okay. Okay, let's take a look at some examples. So we have researcher Elizabeth Kavavic. They studied the factors that affect eating habits of adults in their mid-30s. And so we're going to classify these as qualitative or quantitative. I'm going to use categorical instead because I like that word better. And I like that it's a bigger difference from the other word. The words qualitative and quantitative, those words are too close together to me. I just don't like it. Okay, nationality. So nationality in this case is not a number, so it is categorical. Number of children someone has. Now, number of children, it would be something you do math with. Um, my daughter Beth has one more child than my daughter Cassidy. It's qualitative. Quantitative, sorry. You do math with it. Household income in the previous year. Definitely quantitative because you could say, hey, I made 10,000 more this year than I made last year. Don't I wish? Now, level of education could be kind of tricky. Generally, level of education is categorical, but if I said something like, so my granddaughter Lydia and my granddaughter Lydia is in second grade, my grandson Lincoln's in fourth grade, he's 2 grades higher than her. Technically, I'm making that quantitative, but in general, level of education would be categorical because we don't usually do math with it. It's just something that you say, oh, look, it's a kindergartner, or they have a bachelor's degree, or sh he has a master's degree, or whatever. So level of education is generally categorical. Sometimes some of these are like a gray area and it depends on what you're using it for. Okay, finally, daily intake of whole grains measured in grams per day. We're measuring it in grams. Grams, that's going to be numerical, so this is quantitative. This makes sense. We feeling groovy?
Are
Okay.
you going to look for us to put categorical on there instead of qualitative?
You put whatever you want. And I don't remember what the homework says. I don't remember if it says qualitative or categorical. You use whichever word you like better. Like if it's on my assignments rather than my open math. Because I think my open math uses both of them, but I can't remember. All right. So we're going to set the qualitative slash categorical aside. We're going to set that aside, put that in your pocket, and we'll talk about that later. Right now, we're going to talk about the quantitative variables because quantitative variables can be put into two different categories. The homework is qualitative? Okay, thank you, Becca. Okay, so we're going to put quantitative variables into two different categories in discrete and continuous. So you may recall discrete and continuous from your algebra classes. If not, that's okay. But it's used exactly the same way. So discrete variables are usually something countable, something that can't take on every possible value in between. So if I was to graph it, so if I was to graph it on, let's say, a number line, let's say this is my number line, it would be dots. I would have to lift my pencil to draw to plot each point. It is something countable. It'd be like, how many kids does somebody have? How many students are in the class? How many TVs did you sell last week? Number of red marbles in the jar. The I would like to say it's always whole numbers, but it's not always going to be whole numbers. It's just something countable. Like let's say that I'm selling t-shirts. Each t-shirt is $5.50. I don't know why that's what I'm charging, but it's just an example. If each t-shirt is $5.50, this is still going to be discrete because if I sell one t-shirt, I earn $5.50. I sell two t-shirts, I am now at $11. Sell three t-shirts, I'm now at $16.50. So I am not going to make $13. I still have to graph it with distinct separate dots. Does that make sense? So it's something that it can't take on every value in between. That would be discrete. I don't believe your homework is going to give you weird things like the selling t-shirts. Just for life purposes, I wanted to make sure that you understood what was going on there. Okay, continuous variables. Continuous variables, they may take on every value in between. If I was to graph it, so I'm going to draw my little number line. If I was to graph it, let me make that prettier. I could start it with a dot and then I could just draw it, keep drawing. I don't have to lift my pencil to graph it. So for example, it takes me 30 minutes to get to work every day, to get to my day job because I teach the high school out in Cave Junction. So it takes me 30 minutes to get to work every day. I have to drive 23 minutes, 23 and a half minutes. I have to drive every minute in between from 0 to 30 in order to hit 30. So the time it takes to get to work takes on every minute in between. So 99.9 times out of 100, 99.9% of the time, time will be continuous. There's always an exception, so I have to just say 99.9%. Time is pretty much always continuous. Height of students in class. Before that kid reached 6 foot tall, he had to be 5'6", 5'6" and a half, 5'7", 5'7" and a half. He had to reach every single height in between before he could be 6 feet tall. So height would be a continuous variable. Time it gets to take to school, I already had that. Distance traveled. You have to travel 2 miles before you can travel 5 miles. Weight of a baby at birth Yes, it is, but I just find that kind of a weird one. But, as the baby was growing in the womb, they did have to hit all of the weights, so I guess that works. I just kind of a weird example. But weight is like weight of something that's growing is going to always be continuous. Height of something that's growing will always be continuous. Time and distance, like if you're in the process of traveling distance, it's always going to be continuous. Any questions on the discrete and the continuous? All right, let's go back to Elizabeth Kavavic. So we're just going to use three of them here. So number of children somebody has. Okay, off topic. Um, You will need the TI-84 calculator for this class. Yes, that's the question. We'll need the TI-84 calculator for this class. We won't be using it till next week. In the forum, in the discussion, I put a link to a, now it's really ad heavy, but there's a link to an online emulator for the TI-84. TI-83 is fine. It lacks a couple of it doesn't lack any of the functions, but we got to enter things slightly different, but that's okay because I can help you with that. I know how to use the 83. So TI-83, if you have that, that's fine. But you will need a TI-84 up until our first test. If you want to use the emulator, you can, but on the test, you're going to need to have one in hand. So you'll have to borrow one or you can check one out for 24 hours from the library or buy one. Yeah. All right, perfect. Okay, so let's talk about continuous and discrete. Um, so the number of children somebody has, I'm not going to have 2.5 children. I'm just not. So this right here is going to be discrete. The household income. So I know that if we break it down to pennies, you could technically call household income discrete, but income is continuous because I had to earn $53,000 and 99 cents before I could earn $53,001. So yeah, you have to be able to you earn the money all the way up to that. So you're continuously earning money. So income, we will make that is going to be continuous. I don't know why my screen just did something weird. Daily intake of whole grains. Yes, technically, you're taking bites, but the you're you have to intake 30 grams before you can intake 50 grams. So it is continuous. Any questions on discrete and continuous? All right. Okay. Before we do levels of measurement, I'm going to give you my little disclaimer. Levels of measurement has been a tough one for many students. What I'm going to do is I'm going to show you what helps me to remember it, and hopefully that'll help you as well. There will be questions on the test for levels of measurement, so you might want to star this. There will be questions on the test for this. I know the test is a few weeks away. This is only the first class, but I want to make sure you're aware of that it's going to be on the test. So what it's going to give you, it's going to give you a variable and it's going to ask you for the level of measurement. So let's start at the top. These two right here are categorical. These two right here are quantitative. Forgot to tell you to take categorical out of your pocket. You can take categorical out of your pocket now. We're going to use it again. Okay. The first level of measurement is nominal. The thing about nominal is that order doesn't matter. This is how I remember it. Order doesn't matter. Oh, I forgot the two T's. Okay, order doesn't matter. There's no naming scheme that like makes you arrange them in a specific way. Like gender, it could be male and female, or it could be female and male. There's no specific way to order it. Right and left-handedness, no specific way. Religions, there's not, these things are things that there's not a specific way you need to list them. There's not a specific order that makes the most sense. Unless my favorite color, I guess you could order it like rainbow or whatever, but still, it doesn't have to be ordered. It doesn't, it doesn't have to be ordered in order to make sense. So nominal level is categorical, but order doesn't matter. That's how I remember it. Categorical, order doesn't matter. I love that ordinal is called ordinal because ordinal, order does matter. It is categorical, but order does matter. So things like grades, A, B, C, D, F, order matters. It would be really weird if I put in the syllabus that the grading scheme was B, D, C. If I did something weird like that, you guys would look at that and say, man, this instructor is crazy. Now, you might say that anyway, but not about the grading scheme. So happiness, you've seen those things where it says like highly dissatisfied, dissatisfied, neutral, satisfied, highly satisfied, or whatever. That there's an order to that. Or how about like education starts with elementary school, then it goes to middle school, then it goes to high school. Then you have an associate's degree, then you have your bachelor's degree, then you have the master's degree, and then there's the PhD. So you have like a specific order. So ordinal, order does matter, still categorical. That's how I remember them. You do you, but that's how I remember them. Okay, let's jump to the quantitative. So these are numbers we do math with. There's a couple of ways that I look at this. So interval level, a value of 0 does not mean absence of quantity. The other piece is that the math you would do with it is addition and subtraction. Uh-oh. Why did it go black? Uh-oh. I have no idea. Give me a second here to figure this out. I might need to pause my recording. I have no idea what just happened. Oh, there we go. Yay! I didn't need to record. I have no idea what happened. I didn't even bump the cord. Okay, so value of 0 doesn't mean absence of quantity, and addition and subtraction can be done. Okay, so let's talk about temperature. If it is 0 degrees, that doesn't mean there's no temperature. It just means it's cold. 0 degrees doesn't mean that there no temperature exists. So absence of 0 or 0 doesn't mean absence of quantity. Now, I would not say it's twice as hot today as yesterday. That's just weird. 3 times as hot today as yesterday. No, you're going to say it's 10 degrees hotter today. I'm adding 10 degrees. Or it's 15 degrees colder today than it was yesterday. Addition and subtraction are the math that you would do with temperature. Same thing with calendar years. The year 0, I mean, there wasn't a year 0, but if there was a year 0, 0 would not mean that there's no time, that there's an absence of time, absence of quantity. There's still the BCE years back before that. And then there's, so 0 doesn't mean absence of quantity. Same with elevation. You can be at 0 elevation, and that doesn't mean that there's no elevation. It just means you're at sea level. You can go below sea level. You can be above sea level. Doesn't mean absence of quantity. I wouldn't say that um, I don't know, the mountain is, I mean, I guess you could say the mountain is twice as high as the other mountain, but I would say something like I went 100 feet up the hill, or the elevation is 100 feet higher than the other. I generally don't say the elevation's twice as high. I guess you could, but it generally doesn't happen. So this is what I mean by value of 0 doesn't mean absence of quantity. So if it's a number, check your 0. Check what 0 means. That's usually what I do first. They give me a number, say the number is, the number is 30 degrees outside. Okay, if we're talking temperature, 0 doesn't mean absence of quantity. So therefore, we're at interval level. Okay, let's talk about ratio. A value of zero does mean absence of quantity, and we can do multiplication and division with it. So a value of zero does mean absence of quantity, and you can do multiplication and division. You can still do addition and subtraction with many of these, but multiplication and division also makes sense. And so it kind of includes the stuff from interval, but it has that one little caveat of the zero does mean absence of quantity, and you can reasonably do multiplication and division. So for example, money in your pocket. If you don't have any money in your pocket, I mean, if a value of zero, there's nothing there. Now, height in feet and inches, a value of zero would mean an absence of the person or whatever. It makes sense. I'm gonna go back to the money in the pocket. I can say something like, I have 3 times as much money in my pocket as you do. He has half as much money as she does. Weight in kilograms, if something weighs zero, it doesn't exist. Time spent watching TV. A time of zero means you didn't watch TV, so zero does mean absence of quantity. All right, questions on this? We're going to do some examples in a second. Does anyone need more time writing this down? 'Cause I know many of you didn't print out the. Okay, let's do some examples. I already wrote these. I keep forgetting to erase those. Okay, gender. It's nominal because there's no order. There's no order there, so it's nominal. Temperature. Temperature, we already used that one. It's interval because zero, okay, I'm going to write no order. And then zero doesn't mean absence of quantity. Absence of quantity. Did I spell that wrong? Okay. Number of days in a college week a student or in a week. Number of days a college student studied this week. Zero does mean absence of quantity, so it's ratio. Lastly, letter earned in stats class. A, B, C, D, F. Ordinal. Order matters. Order matters. Questions, comments, queries, concerns? All right. Okay, we are done with chapter 1. Chapter 1 is done. You have enough information to do your chapter 1 homework at this point. Um, I know that we're like have 15 slides left, but I'm going to let you know that the next 15 slides go by quicker than the first 20 that we did. So the rest of it is pretty fast. I think I said this in the welcome video. We will pretty much never take the whole class. Every once, I think probably once every third term, I will, the class will take all the way to 720. It almost never happens. The only times it's happened is when people have had a lot of questions, or I don't know, so it pretty much never happens. So I'm just letting you know most of the time the class will end early. And then I just wanted to let you know. And then that gives you time. If you've like set aside this block of time, you don't have to tell your family, my class got done early. You can just jump into your homework and just don't tell them and just work until 7:20. All right, we're now going to jump into chapter 2.1 if you keep track of those things. I am not going to finish section 2.1 this class. I will finish it on Thursday. So we're going to talk about qualitative data. So you can put the quantitative data in your pocket. We're not going to jump back at that for the rest of this class period. So put the quantitative in your pocket and we will deal with qualitative or categorical. So reminding you that the qualitative data is either words or numbers we don't do math with. So this is what we're going to look at right now. We're going to look at a frequency distribution. All this does is organizes our categorical data in a table. That's all it does is it just organizes it nice and pretty in a table. It doesn't do any kind of inference or anything like that with it. It's just going to organize it and make it pretty. And we're going to do some graphs too. All right. So these are the ways that we can organize our data. So when you collect the data and you haven't organized it yet, it is raw data. It is raw when it has not been organized yet. I think of it as raw data is data that has not been cooked. It is raw. So if I'm pulling M&Ms out of a bag of M&Ms, I'm going to pull it out. I'm going to be like, okay, red, brown, blue, green, green, red. If I just list them all out exactly how they came out of the bag, haven't organized them at all, that's raw data. The ways that we can organize them is we can do tables, we can do graphs, or we can do numerical summaries. You've seen a numerical summary. Let's look at some tables and graphs. Okay, first we're going to look at the next slide. It's going to have a whole bunch of M&Ms. This is raw data. I just typed them out as I took them out of the bag. This is really hard to read, really is, because it is just a wall of words. It is really hard to read. So on the next slide, I organized it. You do not have to show the tally marks on your frequency table unless you want to. I just showed them there because I just tallied them up as I counted them. So notice that I have 12 brown ones, 10, 11 ones, 9 red ones, etc., etc. So this is a frequency table. All that frequency means is how frequently does it show up? How many times did I count that one? How many times does it show up? That's all that frequency means. Okay. So relative frequency is a little bit different. So if I had, let's say that I had 3 different bags of M&Ms and each M&M bag had a different number in it. So it's not going to make sense if I say, okay, well, your bag only had 10 brown M&Ms, but my bag had 12 brown M&Ms. Because if they have different numbers in them, it's like comparing apples to oranges because you don't know what percent of your bag was brown M&Ms. So we use relative frequency to make it so that we're comparing apples to apples. So the way we calculate relative frequency, it's something that you've done before. I'm sure you just didn't use this fancy name. What it is it's a proportion. We can turn it into a percent if we want. But you take the frequency, how many times does it show up, and divide it by how many total we have. So how many times did the brown M&M show up, divided by how many total M&Ms I have. And we can make a new table with these relative frequencies. And it's really nice because now I can compare my bag of M&Ms to everybody else's bag of M&Ms so that I'm comparing well because I'm using the proportion of my bag that is brown M&Ms. No, I don't even care about the brown M&Ms. I like the blue ones. Anybody old enough to remember when there were no blue M&Ms in the bag, but there were the light brown ones? Okay, I'm glad I'm not the only one. I'm figuring out it's crazy. Okay, so this is now, I have my frequency on there still, but now I have my relative frequency as well. So I have 45 total M&Ms. So I did 12 divided by 45, and I got this right here. Then I did 10 divided by 45, and I got this. And I did that all the way down. So I just did this math all the way down so that I could get the proportion of the bag that is each of these colors. Yes, you could turn it into a percent if you want. I could say that this is 26.67% or 22.22%. All the way down, you can just change those to percents if you want, or you can keep them. I don't care either way. My open math is finicky, though. Be very careful paying attention to what they are telling you to do. Sometimes they'll say they want a percent. Sometimes they'll say they want the decimal. So be very careful. I don't care. If I give you a test and I say to tell me the relative frequency, I don't care if you put 0.2667 or 26.67%. I don't care which way you do it. But my open math is picky. Questions so far? Are we doing okay? All right. So A bar graph. You guys have seen thousands of bar graphs in your lifetime, I am sure. Even if you're very young, you've seen thousands of bar graphs in your lives. I'm going to be very specific about what a bar graph is. You're going to learn about histograms next week, and so we'll show you the difference between them next week. So a bar graph, you label each category of data. You can either use a horizontal or vertical axis, and then on the other axis, you're going to have either the frequency or the relative frequency. All of the rectangles need to be an equal width. The height of the rectangle is going to represent the frequency or the relative frequency. I'm going to show you pictures. It's going to make more sense. Okay, we're going to use the M&Ms. I don't know what's going on there. Okay, this is the frequency table for my M&Ms. Here's my bar graph. Important things. When you are making a bar graph, you need a title. You need titles on your axes, and then you're going to label your bars. If you are making a bar graph, you need titles on both axes, and you need a title for the whole bar graph. And I'm going to erase these because they're ugly. So notice how my horizontal axis is the color. Then I list the colors out, have these nice pretty little rectangles, and the height of the rectangle corresponds with the frequency, how frequently it shows up. I know you guys can read bar graphs, but it is good to start from scratch, especially first lesson of the term. It's nice to have some easy stuff to look at, right? Sometimes it's really nice to be able to go, okay, this is easy. I can do this. So you can do it anyway. Even when it gets hard, you can do it. You can do hard things. Think about all the hard things you've done up until now. You've got this. All right. So let's talk about a relative frequency bar graph. It's going to look almost identical. The only difference is my vertical now says relative frequency. I didn't want that. And I have the proportions on the side instead of the frequencies. So now it's just the proportion. So brown was 26.67% or 0.2667. So the height of my graph corresponds with that height. So that way, if I was, let's say I was comparing two different bag of M&Ms, I could have another bar here for the other bag of M&Ms, and I could I could put another bar next to it that could show the how the colors are in there, and we'd be using relative frequency. So I would be comparing apples to apples. Questions about bar graphs? And I told you it was going to go fast. Look, we have 2 slides left. But after the last slide, we're going to talk about the lab that we're going to do on Thursday, and I'm going to tell you what data you're going to need for that lab. Okay, so I don't think your homework will ever mention a Pareto chart. I don't think it ever mentions it, but I am going to mention a Pareto chart because it is part of the standards that I have to teach. So I will mention it once, and I'm going to tell you before I took stats 1,005 years ago, or 15 years ago. Before I took that stats class, I had never heard of a Pareto chart before, but it is one of the standards. So all a Pareto chart is it makes it pretty. It puts them in a decreasing order. So it puts the one with the highest frequency all the way to the left, and then it steps down. So it just puts them in order from the highest frequency to the lowest. That's all it does. And here it is right here. This is the Pareto. So I just rearranged them so it's from highest to lowest. And I'm pretty sure that my open math doesn't ask you any questions about the Pareto chart, and I will not put it on the test or anything, but there it is. It exists. Now you know what one is. You've heard of it. So there we go. That was my last slide. So before I talk about the lab that we're going to go through on Thursday, are there any questions about today's material? Okay. Hopefully I can get a blank screen. I had a blank screen back here. Hold on a second here. There we go. Okay. We're going to have a lab on Thursday. So the lab isn't due till next week, Tuesday, but I'm going to walk you through the lab on Thursday. So if you want to have your data ready, you're welcome to have your data ready. So I'm going to tell you what we're looking for. So you're going to have 20 data values each. I want 20 data values each of number one, categorical. I don't want you to spend too much time on gathering your data. I don't want you to, um, spend a ton of time researching. I don't want you to put polls up for each of these. You can, but there's going to be future times of gathering data that are more critical that you have good data than right now. The confidence level is something you're going to learn in chapter 9. The question was how we determine the level of confidence. That's something we're going to learn in chapter 9. So you don't need to worry about that right now. It's determined by the sample size and how confident you want to be. That's that's the simple answer. Okay, so I want 20 data values of categorical. Feel free to look in your closet and look at 20 articles of clothing and what color they are. Sit in front of your bookshelf and look at 20 books and what genre they are, or 20 books and what color their jacket is, or whatever, or whether they're paperback or hardcover. Sit on the front porch of your house and look at 20 cars going by and write down the model, the make of the car, or write down the color of the car. Grab a bag of Skittles and empty them out and look at the colors. I don't care. Just do something simple. 20 data values. Okay, number two, continuous. This one is a little bit trickier, but I'm going to tell you, we are going to use the continuous data that you collect for lab 1. We are also going to use it for lab 3, or sorry, yep. We're going to use it for lab 2, and then we're going to use it for lab 5. So this is the one, if you put any time into any of them, the continuous is the one you're going to reuse. But I still don't care if you don't have to put a lot of time in. It doesn't matter to me what your data is as long as it's continuous. Here's a couple of things. So if you are somebody that takes a lot of walks and maybe you have an Apple Watch, you can look at the length, how much time your last 20 walks were. That's a cool one. You can, if you like vinyl or even your Spotify playlist, open a Spotify playlist that has at least 20 songs and look at the length of those songs. That's a good one. Um, Trying to think of what take pick 20 days out of the last year and look at the high temperature for those 20 days. Look at 20 different cities and look at the rainfall, annual rainfall in those 20 cities. I'm just making stuff up as I go along. Hopefully, you're kind of getting an idea of what I'm looking for. It doesn't matter as long as it's continuous. I do really like the going for a walk. I've never suggested that one before. I kind of like that one though. Okay. So this is the one you're going to use again, the continuous. So just letting you know, but it doesn't matter to me what it is as long as it's continuous. Okay, number 3, discrete. Discrete. 20 data values of discrete. Once again, you don't need to make this anything crazy. Look at 20 books on your bookshelf and how many chapters are in those 20 books. Um, oh, what else can we look at? If you know off the top of your head how many kids 20 of your friends have, or like maybe social media 20 people have, or look at vinyl. I love vinyl. Look at vinyl and look at how many songs are on each album. What else could it be? How many pets 20 of your friends have? See, anything like that, anything countable. So just pick 20 data values of each of those. Any questions about what you need for the lab?
I think my only question is whether you want the lab to be like graphed. Is
Okay,
that what you're asking?
all I want you to do right now is collect your raw data. I'm going to walk you through the lab on Thursday on how to do it. You were asking the right question once again, but I will walk you through how to do the lab. All I'm looking for you to is just to collect the data right now. So collect the data and bring it Thursday. And Thursday, I'm going to walk you through how to do the lab, where to find it, how to download it. If you've never if you've never used Excel before, I treat it as if you've never used Excel before. And I want you make sure that if I do something that you're like, how did you get that? That you ask me, how did you get that? Because sometimes I forget some of the little things because I did learn Excel a long time ago. So sometimes I do forget some of the little things, but just bring the data and I will show you what to do with it. So just collect it. Try to have fun. So that's for
You
the
said the
lab.
lab was Thursday.
What was that?
Did you say the lab was due Thursday or Wednesday?
The lab is due Tuesday of next week, but I'm going to teach you how to do the lab on Thursday. All right. So at the end of every class, I ask, are there any questions for on the recording while we're still being recorded? And then once there's no more questions that you want to be recorded for everybody to watch, then I turn off the recording and then you can ask any questions that you don't want recorded. So we are currently still being recorded. Any more questions that you want on the recording so other people can hear the answers? You can type it in the chat if you want, or you can ask it. Okay, I'm going to turn off the recording. Okay, I can find the button.